All right, class, Mr. Hanson again. We're going to continue our conversation today about exponents. And what I'm going to try to do initially here today is to generate an idea of what negative exponents are. So what I'd like to do to introduce this topic is look at a pattern. Okay, so right here on the screen I have 2 to the 4th power. 2 to the 4th power is 2 times 2 times 2 times 2, which is 16. And what I'm going to do for the pattern is just decrease our exponents by 1 and see what happens to our answers. 2 cubed is 8. Okay, I think we all know that 2 squared is 4. So if you start looking at this column of numbers here, notice what's happening. It's getting cut in half every time, right? So let's continue and see if that pattern holds true. If I drop the exponent 1 more, I get 2. Well, 4 divided by 2 is 2. So using this pattern, that must mean that 2 to the 0 power, okay, what's half of 2, right? Half of 2 is 1. So 2 to the 0 power must be 1. Let's carry on. If I continue to drop my exponent by 1, 2 to the negative first must be half of 1, which is 1/2. 2 to the negative second, half of a half is a fourth. Okay, and I'll do one more. 2 to the negative third must be 1 over 8. Okay, and for these negative exponents, let me just rewrite this. I want to make a point here. This is 1 over 2 to the first, another way to write that. This is another way to write it would be 1 over 2 squared, right? 1 over 2 squared is 1/4. And this is 1 over 2 cubed. So I want to see if we can come up with a rule eventually to show how we can go from this column straight to this column. And hopefully you can see a pattern. I'll just leave this up on the screen for a second, see if you can see a pattern and what we can do. Okay, so out of this little exercises we learned a couple things. We learned that 2 to the 0 power is 1. And it turns out, class, that any base to the 0 power is always going to equal 1. So here's the rule. For any non-zero real number, remember non-zero just means it can't be 0. And we know what real numbers are. Real numbers are all rationals and irrationals. For any non-zero real number, any base a to the 0 power is equal to 1. That's a very important fact. So for example, 3 to the 0 is equal to 1. We could have x to the 0 equals 1. We could have the quantity xy raised to the 0 power. That is 1. Any base raised to the 0 power is always equal to 1. So that's a fact you're going to want to know. Memorize that. In fact, I'll make sure you write some notes. Okay, so that's the one thing we got out of that pattern we just looked at. The other thing is we can pull this, hopefully. Let me just get this back. Okay, remember this? When we started looking at negative exponents, hopefully you see a pattern here going from this column all the way to the end. Notice that the exponent that was negative now becomes positive, but we move that whole power in the denominator and we put it over underneath 1. Okay, so that's the next property. This is called, I guess we'll call it the negative exponent property. Try to get this focused here for you. Sometimes this thing has a problem focusing, so I apologize. Come on. The lights went out. All right, I guess I'll continue writing. Negative exponent rule. I'll call it the property. If you have some base a to the negative nth power, and again I would write this in your notes, it's equal to the reciprocal 1 over the same base, but we're going to raise it to the positive. Okay, so it turns out that negative exponents are fractions. Negative exponents are fractions. Okay, so let's look at some examples. 6 to the negative third power. Well, if we use this rule, we're going to go 1 over 6 to the third power. And 1 over 6 to the third power is the same thing as 1 over 6 times 6 times 6. And if you don't know that, let me clear that out. 6 to the third power is 216. So 1 over 216 is 6 to the negative third power. Okay? Let's do a couple more. What if I had 3 to the negative second power? Well, if we follow the pattern, it's 1 over 3 squared. Notice the exponent went from negative to positive, and now we can simplify that to 1/9. What if I had something like this? What if I had 4x to the negative second? Notice the parentheses. That tells us everything inside the parentheses is raised to the negative second power. So we follow the rule, 1 over, we put the 4x on the bottom in parentheses, but now we square it. Now remember yesterday we did the power property. Remember these exponents are 1 there, so we multiply exponents when you have a power raised to a power. So this would be 1 over 4 squared times x squared. And how I got that is I multiplied 1 times 2 to get this 2, and then this 1 times 2 to get that 2. And we can go one step farther. This is 1 over 16x squared. So if you notice the base is in parentheses, you have to raise everything in the parentheses to that negative second power. However, if you look at this next example, it's a little different. What if I did 4x to the negative second? Notice the difference between the two. See if I can get them on the screen. This one does not have parentheses. So in this case, class, this means 4 times x to the negative second. So this would be 4 times 1 over x squared. It's going to produce a different answer. 4 times 1 is 4. That goes on top. X squared is on the bottom. And you can see these two answers are not the same. And the difference was, remember, one was in parentheses and one was not. So just pay attention to that. That's very important. Okay, let's give you a second to digest. All right, let me do some problems where there's negative exponents on both the top and the bottom. So this can be kind of confusing. Let's say I have 3 to the negative second on top and 4 to the negative third on the bottom. Here's my simple rule. If you see a base with a negative exponent, it's in the wrong place. The power's in the wrong place. So what I mean by that is I'll call this downstairs underneath the fraction bar. On top of the fraction bar, we'll call that upstairs. So we have upstairs and downstairs. If you see a negative exponent, it's in the wrong place. So you got to move it from upstairs to downstairs. And remember, when doing so, you got to make the exponent positive. Likewise, this 4 to the negative third is downstairs. However, it's negative exponent. We don't like negative exponents. In fact, none of your answers should ever have a negative exponent in your answer unless it tells you to. Okay, so this is in the wrong spot because it has a negative exponent. So that's going upstairs. Change it to positive. Okay, and we could figure out what that is. Let me just do this quick. 16 times 4. So we have 64 over 9. 64 ninths. Let's do another one like that. Let's say we have 4 to the negative second over 5 to the negative fifth. Again, if you have a power with a negative exponent, it's in the wrong position. If it's upstairs, move it downstairs. If it's downstairs, move it upstairs. Now anything, well, I guess I'll show you that next, but anything with a positive exponent stays where it's at. So this would be 5 to the fifth and 4 squared on the bottom. This is upstairs, negative exponent in the wrong place, so we got to move it downstairs. Change your positive or exponent to positive. Likewise here, this is downstairs, 5 to the negative fifth, but since it's negative exponent, it's in the wrong position. Move it upstairs, change your exponent to positive. All right, let me just look at a different, more challenging problem. What if I had 7x to the negative third, y to the fourth, over t to the seventh, negative seventh? Let's do this one. So the whole idea is to simplify this. Well, if you follow the rules, if you have a positive exponent, it stays where it's at. But if it's negative, we got to move it. Okay? And notice this one has a coefficient of 7. Okay, the numbers just stay where they're at, unless they have a negative exponent also. But so the 7 would stay on top. Negative exponent is in the wrong place, so we got to move that downstairs. This exponent's positive, so that's in the right spot. We'll leave that there. And then finally, t to the negative seventh, negative exponent, wrong spot, so we'll move that upstairs. So this would be your simplified answer with no negative exponents. Okay, you'll get some practice with this. All right, so in general, this is called changing from negative to positive exponents. Changing from negative to positive exponents. And I would write this down in notes. The rule is this: if you have a to the negative mth power divided by b to the negative nth power, remember if they're negative and they're in the wrong spot, so we're going to put b to the nth on top, a to the nth in the basement. So this is something you might want to throw in your notes. Okay, one other example I want to look at with this. What if your base was a fraction? So let's say you had 3/5 to the negative second power. Well, if we follow the rule, we're going to have 1 over the base, which is 3/5, and we're going to change that exponent to positive. So if we keep doing this, simplifying it, we're going to get 1 over 9/25. But then, if you have 1 over a fraction, the rule is take the reciprocal. So we will end up with 25/9. But what's a quicker way to go from here to here? So if your base is a fraction, what you want to do is flip the fraction over, take the reciprocal of the fraction, and then change the exponent to positive. That's the direct route. So flip the fraction, change your negative exponent to positive. If it starts with positive, you don't have to worry about it. So this would be 5 squared over 3 squared, which is 25/9. And that's the same thing we got before. Okay, so watch out for that. Finally, so yesterday we taught you the product rule and the power rule of exponents. Now we're going to do the quotient. Quotient rule, remember, is when we divide. Quotient rule for exponents. So let's say, for example, and I'm going to start off really basic. What if we had x to the fourth divided by x to the third? Okay, the quotient rule is when we divide. Now, the key to use this law or property is the bases have to be the same. So if we did this the long way, if I wrote 4 x's out on top and 3 of them on the bottom, because it's all multiplication, we can cross off common factors. So there's a pair of factors we could cross off, another pair, and we're left with x to the first power. So that's the answer. Now the question is, how can we go from this expression directly to the solution? Okay, let's do one more and see if you can see the pattern. What if I had 2 to the fifth divided by 2 to the third? Well, that would be 2 times 2 times 2 times 2 times 2 divided by 2 times 2 times 2. And again, cross off pairs, cross off ones basically, and we're left with 2 squared. So how can I go from here to here? Anybody have the solution? What's the trick? Well, if you said subtract exponents, you are correct. So the property for the quotient rule is this. And this is another rule you might want to write down. If you have a to the nth power in general over a to the nth, notice the bases are the same. Okay, you're going to just subtract the top exponent minus the bottom one. Okay, we'll look at a couple examples really quickly. Let me get a marker that works a little better. So if I have 4x to the 7th divided by x to the 6th, okay, the 4, if this was, let's put a 2 there also. If there's coefficients, you just divide those numbers like normal. So 4 divided by 2 is 2, but then the exponents we subtract. And you technically don't have to put that 1 there. You can write it as 2 to the 2x. If we have x to the 7th, y to the 10th, over x to the negative 3rd, y to the 10th. Let's make that one interesting. Even though you have a negative exponent, you can still subtract. But be careful. What's 7 minus a negative 3? Oh, it changes to addition. So be careful for that trap. So this is x to the 10th power. 7 minus a negative 3 is 10. And then what's 10 minus 10? Well, 10 minus 10 is 0. But we know that any base to the 0 power is just 1. So this would just be 1. So we don't have to write it. So that answer would be x to the 10th. All right, I can't show you every kind of problem, but if you have questions when we go work on these tomorrow, let me know.